and we're good to go. So I wish you a nice afternoon. I'm Thomas, and I would like to thank our sponsors for making this event happen. Here you can see the awesome guys who contributed to let us meet here and share our experiences. And I'm coming here from the Czech Republic. I'm a solution architect. I've been working with Dynamics CRM. Before that, I used to be a ASP.NET developer, so I ran some traditional .NET projects. That's where my experience comes from. And these days, I'm doing projects on Power Platform, and I'm trying to show people around me how you can bring some practices from the past to the platform of the future, and how to overcome some of the issues that we're facing as professional devs working with Power Platform. I do have a team in Czech Republic, so I'm in a business of trying to make projects very efficient because we run like enterprise application projects. So we do small apps, big apps, all sorts of things. And since these are tens of projects that we deliver, I'm really after some consistency and supportability of the solutions that we create. So we invested a lot of effort into automating our DevOps processes and the developer experience that I will be talking about here today. As you might have noticed while working with Power Platform, the tools have not been as great as we might have been used to within other platforms. So this story is slowly changing, and there are people at Microsoft working on this. So it's getting better with every time I deliver this session. I'm thinking whether I should remove this slide already or not. But yeah, we're getting some new things. From my perspective, I was really after trying to get rid of these situations in your team when you need to collaborate in a team of multiple people. You need to work with some legacy code that you created a couple of months or years ago. You want to be able to troubleshoot quickly, and it can be a challenge sometime in Power Platform, and that's why we consider using things like source control and some IDE extensions, which can make this a little bit less painful, let's say. So these are some traditional pains that devs are facing. For myself, I really hate clicking in the web browser and looking at the spinning wheel, waiting until the solution maker does something. So I'm trying to move most of the stuff to my VS Code IDE, and that's what I will be demonstrating today. Let's make some setup for this session. So this platform is positioned to serve citizens and pro devs. We will be looking into how we can use some existing tools in larger teams to improve their development workflow and make the people more happy, and maybe possibly attract some new developers from the traditional platforms as well, because we can show them that it's actually possible. So to resolve this, or to improve the situation, I'm trying to split it into multiple areas. So first is your development environment, where you want to improve how you work with scaffolding the code and working with the APIs and your CLI tools. Then I'm trying to bring some sort of structure to projects, so you can make the source code more readable. You can quickly create a table in Dataverse and examples like that. And then I'm customizing the build system, which is supposed to produce something which I can import to Dataverse from my source control. And there are some customization points, extensibility points, which I can use in the MS build for that. And the last area is the DevOps automation, where we can use many functionalities of Azure DevOps to automate the process. This session would be enough for a full day workshop, so I will show you just a little bit of automation and steps that we're using. So if you see my session somewhere else, it is likely that I will be showing a different part of this, but today we'll be initiating a repository and deploying a solution that you built code first from your IDE. The things I'm showing require you to touch the exported definitions from Dataverse, which is not really supported. So this is on your own risk. It's been working for us for a couple of years, and we've been getting away with that. But this is not an official recommendation from Microsoft. So let's start with introduction for those of you who might have been new to this. When we create a Power Platform environment within a Microsoft tenant, we can create solutions in those environments, and we can put components there. These solutions can help us organize the code, export the definitions, and move them to different environments. And this is all thanks to Dataverse, which is not just a database, but it's a backend which can also work with the metadata for your application. So all the component definitions are actually stored in Dataverse and exported with the Dataverse solution framework out of the environment, and then these definitions can be stored in your source control. So solutions, there are two types. You can have either unmanaged or managed solutions. Unmanaged solutions are rather for tracking the components and allowing you to export them from the environment. This will likely get changed in the upcoming months, the workflow, because Microsoft is working on the native Git integration, which will help you skip some of the steps when you're trying to bring those customizations and components to your source control. So it will be a little bit easier, but it is still important to know the difference between these two, because solutions are not going away. They're a deployment artifact which allows you to move the compiled code, the artifacts between different environments. When you take the solutions, you likely want to have your project segmented into multiple solutions. So there are some things which can help you better troubleshoot the code, uninstall some of the components, and this usually leads to a set of solutions that you need to deploy. And for that job, there is a Dataverse package which can be deployed through a package deployer tool, and this can contain multiple solutions, configuration data, and some C# code which can run before, during, or after the import, where you can perform migrations or some validations and after deployment steps automatically. I will be showing you how to create a single repository, a single Git repository, because I prefer monorepo style. This means that you put multiple projects into a single repository, and I've got multiple reasons for that, because usually our projects for customers, they have multiple solutions, multiple components that we're building, and since we're using Azure DevOps for code review, it is usually quite difficult for code reviewers to deal with multiple dependent PRs across multiple repositories. And also we have a standardized CI/CD workflows which you don't want to maintain across multiple solutions in the project. So I will be trying to put everything into single repository, track the dependencies locally, and build a deployable artifact from the single source. We'll be using some tools. So first of them is .NET CLI. So when you install modern .NET, meaning .NET 5 Plus, you get this new .NET something command set, which you can use to invoke MS Build or the templating engine or different build targets as part of the MS Build pipeline. Then we'll be using Power Platform CLI, which can help us with some operations like packing solutions, creating packages, deploying packages, moving configuration data, and calling requests to the Power Platform and BAP API, which can automate some operations on the environment level. And then we'll also be using Azure CLI, which can help us work with Microsoft Entra ID and Azure DevOps organization, where we'll be integrating the code and running the deployment workflows. I also created two projects which I published for the sake of this demonstration. These are .NET templates and MS Build extensions. So to expedite some of the steps in the demo, I'll be referencing these packages. They're open source, so you can have a look at how these things are built and possibly contribute or fork it for your own purposes. Okay, so let's get to the demo. As you've noticed, I'm talking very fast because we have very limited time. The demo will be also very fast. There is a lot of text, but don't worry. I have posted all the steps on my GitHub, so you will be able to do that at your own pace back at home. I'm just trying to show you how the things are working and what kind of steps you need to perform to achieve the result. So don't worry if you don't catch the exact step. You'll be able to get back to them later. So we'll be creating a repository, pushing the code to Azure DevOps, creating environments, deploying the artifacts there, making some changes on the environment, bringing them back to the source control. Then we will set up our CI/CD orchestration, and if there is time left, which likely won't be, you'll be adding a PCF to that solution. So let's now switch to VS Code. I was trying to see if the text would be readable, and for the first time in my life, I switched my IDE to the light mode. So, but that should be more readable for you. Uh, I'm not that kind of person with white VS Code. Uh, yeah, so let's start with some prerequisites. If you have not worked with .NET or VS Code or Git, there are some steps that you need to take to set up your machine. So you basically need to install VS Code, .NET SDK. Since I'm running this on Mac, I'm also installing PowerShell with the .NET Tool command. Then I can use PowerShell globally in my terminal. I'm setting up the Git client, which you can download and install on your machine. And then I'm adding the Azure CLI, Pack CLI, NuGet package source, and extension for working with Azure DevOps. And finally, the Pack CLI for handling the Power Platform commands. There is one note here, important note. There are like three flavors of installation that for Pack CLI. So you can either download a VS Code extension, which then handles the acquisition of the Pack CLI internally, or you can install it with .NET Tool, like the Azure CLI, but this is .NET 8 modern CLI, which misses package deployer and customer migration tool, which have not yet been rewritten to .NET Core and modern .NET. So if you install this, there will be some commands missing. And if you're on Windows, the official way of how you can acquire all the assets is through this MSI file installer, which can make sure that the thing is available globally in your terminal on your machine. So let's move to initializing the Git repository. So I prefer to work in the source control in a specific flow. So we will be using trunk-based branching strategy. If you've heard about different branching strategies, then you are likely familiar that you need to deal with a setup of multiple branches and how you're going to merge them together. For the simplicity, I'll be using one single branch called main, which will be protected from having changes pushed directly to it. And from this branch, all the developers will be synchronizing, and when they start their work, they will always create their own Git branch for implementing the change set that they're working on. Yep. So you can execute this. So after I run this, you can see that my repository has been initialized. So the VS Code source control extension will start showing you the changes locally that you make, and you will be able to commit those. And as you can see here at the bottom, there is my current branch. So I'm working on the project setup branch, which is like my copy of the source that I'm making changes to. Okay, the next step will be creating some folders and things in my repository. So I will create a git ignore, which is a file which tells the Git source control manager to ignore some files from being committed and synchronized to your source control server. And we can use .NET new command to pre-populate it with some standard items for .NET projects. Then I will be creating a .NET solution. This is not a Dataverse solution, but .NET solution file. And this file keeps track of all the .NET projects which are present in your repository. So you can then build all of them with a single command, and it will resolve all the dependencies because you're keeping track of all the projects in this file. And I will also be creating a folder here for the source directory where we'll be putting the source code. There is a recommendation when doing monorepos that you should try to limit the directory nesting level to like 2 or 3 levels, because if you keep nesting more than that, people tend to make the repository layout very complicated. So if you look at other platforms like front-end development, they usually limit monorepos to 2 levels of hierarchy for the buildable projects. So don't overdo it with folders. So let's run this. Now we can see that we have the source folder here, which is empty. We have the git ignore file, which lists all the file which my source control should ignore. And I do have the Visual Studio solution file here. If you're familiar with this, you know that it's kind of a pain in a code review to resolve merge conflicts in this old file, which is not really nicely readable. Microsoft is changing that, and they are working on a new solution version file, which will look more like the CSproj style SDK style projects. So that will be a good update for us, but it's not yet officially available in the CLI, so I won't be able to show it today. And let's move on to the third step, in which we will create a Dataverse solution project. And this project will be used for initializing a database schema, so deploying our tables and columns to Dataverse. You can use PAC CLI, Power Platform CLI, to initialize a project, and then you could synchronize the solution with Dataverse and start adding components there. I have changed this a little bit from the official documentation process documented in Microsoft Docs, and I use the .NET new templating engine with the templates, which can be found on GitHub, which can create a solution, add it to the solution file, and do some sort of monkey patching to the CSproj file to make it work with the solution file and resolve some common bugs which are there. So I will run this, and you will see that my source folder will be populated with a new project, solutions.data model, and it contains the .NET project system file, which describes how the project is supposed to be built. It imports some NuGet packages for Power Platform, which describe build targets, so the steps which are supposed to be taken during the build process, and it can also outline dependencies, local or from the NuGet package source. So this is now empty, so the solution contains only description and name, and there is really nothing at the moment. And let me just quickly jump to the repository to show you how this template works. So with .NET Templating Engine, you've got 2 options. This is not quite visible, right? Can I turn this into white mode? I'm not sure. Yeah, so let's try it with the dark mode. So when we're creating a solution, we can use a PowerShell script, which does some, patching of the file, but it begins with pack solution in it. So we're actually using the Power Platform CLI here, but there are some steps with descriptions. I won't be going into that right now, which can help you, do the rest of what you will see in the demo. You can also use .NET templates without scripts. So I have a JavaScript library or TypeScript library example here, where you can define the files which are supposed to be created in your project when you initialize it, and the .NET templating engine can replace those placeholders with parameters that you define when you're creating the project. So this is how you can author your own templates. Okay, let's move to the next step. So now we'll be creating a table. The usual approach would be import the entity to your Dataverse environment, then open Power Apps Maker, create the table, and then export it, unpack it, or sync it to your source control. Here I'm again using the .NET new templating engine to create my table. You can find the reference for those templates here on the GitHub repository. So there are some few examples. This is not really production ready, but you can take it as an inspiration. So let's run this. And our declarations folder, where we're putting the Dataverse metadata, will be expanded with a new table, formerly called entity, where you can see the default forms, default views, and the entity definition, so the standard attributes and standard metadata for the table. All of the changes that we are making to the repository, you can see here in the source control extension in VS Code. Okay, so the next step would be creating another solution, which we will call UI, and we will place presentation layer components there. So the thing is that I like to separate the database, business logic, and presentation layer in my repo, because it can make it way easier to locate problems, troubleshoot them, uninstall corrupt components from the environment. And I just like this sort of housekeeping where I keep things separate. But with tables/entities, it's a little bit more difficult, because when you're creating a form within a solution, it is actually tracked under the table definition. But with managed solutions and their layering capabilities, you can actually create the table within the first data model solution and then contribute a form to that same table from a different solution. So that's what we'll be doing here. So we're creating a solution called UI, and we're adding the table that we created previously as an existing to the UI layer. So let's now execute this so you can see what it does. So now we have two projects here, data model and UI. In the data model, we have the table, and in the solution file, it is referenced with the behavior 0, which means like introduce this to the environment. And then in the other solution, we have the same table added, but it doesn't contain all the definition, just the difference, just the things that we'll be adding to the previous solution. And it has behavior 2, which is like we don't have metadata here, we're not introducing it, we're just bringing in some changes. So the entity is here, it doesn't contain anything at the moment, but it will add a form or view or anything to the metadata. We can do it here from the UI layer. Okay, the next step would be creating a package deployer package. I will be adding those two projects to a third project called main package, which I can initialize through pack CLI using pack package init command. And by adding references to it, I will make sure that when I build the package, it will pull the solution zips to the package so they can be deployed. So let's run this. So now I've got a new project here. it contains a C# file where I can customize different stages of the import. So I can run some operations before import, connect to the environment, check what it's there, validate what kind of changes I'm bringing in. You can work with versions here, and you can even run logic between import of individual solutions. So this could be used for migrations, for example, when you need to do some changes to the table and migrate the data as part of your release. So this can go here to this file. And if we open the project file, you can see that there are two references in the project system which point to the other .NET projects in your repository. So when I run build on this, or more specifically publish, because they use publish target here, it will pull the resulting solutions from the other projects, put them in the package, and then it will automatically construct the import config XML file, which will contain the solutions which are supposed to be imported. You can either do it manually here, or you can let the MS build target from Microsoft to generate this file for you, which is the default setting when you create it through pack package init. And you can even include some configuration data here, which will be imported after your solutions are present on the environment. Okay. So that would be for the package. We also should not forget to add it to the solution file, so we keep track of all the projects in the repository here. Okay, now we will try to build the solutions. So as I explained previously, there are two types of them. You can have unmanaged solution, which are useful when you need to change something on the live environment. So you use the unmanaged format, which you import to your development environment, make some changes, and then sync the changes back to your local repository. This workflow will be improved with the newly announced Git integration capabilities. Also, there will be some format changes, so the XML definitions might not look like exactly the same as they do today, but that is yet to be resolved by Microsoft. And then if you have your artifact ready, you use managed solution to import it to downstream environments like testing and production. There might be a situation where you need to import a managed solution to your developer environment, and that's when you want to create layers of those solutions. So for example, if I have the table in data model and UI on both places, I need to be importing the data model as managed and UI as unmanaged, so I can keep track of the difference and then export it to source control. So that's one exception. Also, there is a thing called managed properties, which you can set on a solution, which can prevent others or yourself from customizing the components in a managed solution. There is one trick which you can use to edit managed solution components with managed properties, and that's when you import your publisher to the environment as unmanaged first, and then you import the managed solutions. That will let you customize that. So these are tricks for setting up a development environment. I try to describe them in the script command, so you can have a look at that after my session. Also, one change which is done by the .NET template for solution initialization is that I'm setting the type of solution in solution XML to number 2, which means both, and that will inform the solution packager tool, which packs the source into the solution zip, that it is able to build both types of solutions, and that the solution contains the necessary components to do so. So when I run .NET build without any other arguments, I will get an unmanaged solution with every project output. So you can see that I do have a data model zip here, solution UI zip here. I could take this and import it to my environment as unmanaged. I can also build managed versions because the Microsoft official build targets, which are dictating the MS build, how the build should supposed to be done, this package, It supports configuration. So I can say configuration release, and when I execute this, it will tell the solution packager tool that we want to build a managed solution. So now I will have two solutions here. Debug is unmanaged and release is managed solution. I can also build a package, but they're not using the build target, but publish target. So when I run this, it will create the package, compile the .NET code, build all the projects which are listed as dependencies in that package, and it produces a zip file which I can take and import to the environment, which contains all the things that I have been creating here. So this file, it can contain data configuration, migration, post-deployment steps, and all the solution artifacts, and I can just take it and import it using package deploy command, or for example, pipeline build tools in my Azure DevOps instance. Okay. So now we want to commit our changes in our repository. So I can either use this UI to review what I changed and then do the commit, or I have my commands here at hand. So when I do git add all, it stages all the changes, and then I can commit it with a message. So my changes will clear up, the commit is in the repository, and now I can start moving further adjustments. So because we want to synchronize this with other people and with our server-side processes, I want to create a remote source control server in Azure DevOps, and I want to push the changes there. So I could either go to the UI, create a new project in Azure DevOps, and create a repository there, and then push my changes there. But I have all the steps listed here in the CLI, so let's run that. So we save some time. I need to authenticate to the Azure CLI. And just like that, I have created a new project in Azure DevOps, and I have created a repository there, and I'm pushing my local repo to the remote project. Yeah, so I got stuck on login, so let's wait a little bit. Okay, I hope my internet connection is fine. Yeah, it's good. And now I jumped straight into the project from the last CLI command. And you can see this is my Azure DevOps project. I can see my repository here. These are my files. All the ignored things are excluded here thanks to the git ignore file. I do have a single branch here called project setup. And now I can continue with the next step. So it is a good idea that you create some sort of a protection for the main branch. So I don't have my main branch created, so I will quickly do it here. You can see that if you use slashes in your branch name, it creates nice folders here. I will also create the main branch. And I will be setting a policy that I need a certain number of approvers on the branch before I can push changes there. This will make people without permissions, like myself on the project, it will just make it impossible to force push their changes to the main branch without going through a pull request. So this is a very good thing to set up at the beginning. So now if I check out the branch policies here, I will have minimum number of reviewers, and this is enough to prevent people from pushing there without creating a pull request. Okay, and now we will create a developer environment. So this is a command from packcli which I can use to spin up a new dev environment. There are 3 dev environments which you can get for free if you sign up for a developer plan. There are some organizations which have blocked the viral SKUs in tenant, so you might not be able to sign up for the developer plan. In such case, I recommend you to create a development tenant which is separate, and you can do all of this for free over there. Yeah. Yeah, sorry for that. So now we're creating the dev environment. It takes a moment. We'll be using this to, do all sorts of modifications which you're not really able to do well locally. So like designing Canvas apps at the moment, or creating cloud flows, because I don't know many people doing the flow JSON by hand. So we will still need a developer environment for that. And as you can see, it's the slowest part of this demonstration. Well, I do some changes occasionally, but yeah, it's kind of easy to make a mistake. Yeah, so let's now continue with making some changes. I likely made a mistake in my demo, so I will open it from here. I can use Pack Tool Maker to jump to the environment. Yeah, this is what I need to do. I first need to connect, and clear the authentication to change it to the newly created environment. So let's do that. So sign in, close the window, and yeah, that's it. And now I can import the solutions there. Yeah, so I can either use package deploy because I built the solution zip that works on Windows. Unfortunately, I will not be able to use it on Mac because that's not ported from .NET Framework yet. So I will execute solution import here, and like this, I can import the changes to that environment, and then I can step in and see the changes there. Yeah, this. Since we don't have much time left, I will now skip this, and you will have to believe me that it works. So I'm canceling that. C4. So yeah, we can make some changes and then we can synchronize them back. So if I now jumped to the environment, I did some modifications, I could then run pack solution sync with package type both, which should pull both managed and unmanaged diffs to the solution, and that will just apply the changes to my projects here. Yeah, so we're not doing that because we don't have enough time. And also one step which you could make is use the configuration migration tool like this. So if you create some configuration records on your environment, you can create a schema file and export the data file to your source control as well. It will come out as a zip file which you can unzip and put into your package project, and then these records which you reference in your flows or wherever, they can also be imported as part of the package import. And there is also a nice way how you can create a zip file automatically as part of your build, and here is an example of what you need to add to your CDS proj file to make that happen. So we're also skipping this. And Now we would commit our changes. So we don't have any at the moment. So I will just make some random change to the form. Yeah, I can see the change is highlighted here, and I will be running the git commands to commit it. And the next step would be creating a pull request. So I have my changes in my project setup branch, and now I want to bring them to the main branch. So I could either go to Azure DevOps and create a PR from the source and target branch. I will just do it quickly here with the CLI. And here I just created a pull request where I can see my change, which was done. I can comment it if I don't like it, and I can have some discussions. We can have tasks here. We can have requirements for validations and stuff like that. And as soon as someone approves, because that was our policy that we created, we can complete the pull request, and that means that it will close it and potentially delete the branch. So now the change is in the main branch. So you can see that I just contributed it here. So now I will be adding pipelines to the project. So I will be creating a new, I will be synchronizing the main branch, which I just modified by the pull request. I'm creating a new branch for adding pipelines. And next step will be adding the pipeline definition files. So in Azure DevOps, there are two kinds of pipelines, the old classic ones and the new YAML ones. So I'm using YAML pipelines here. And with this command, I created the pipeline files. Yeah, and I'm in the data model folder. That's not where I'm supposed to be. So let's run this again. Because I'm here in Git, I can discard the change, which was unintentional. And I created two empty files where I will be putting a template for a pipeline. So the build pipeline will be used to generate the package as we did locally. So you can see that we're using a Windows agent here. We're calling .NET publish with this command. We're copying the resulting package to a folder, and we're publishing that as an artifact. So the second pipeline, which will be deploying the package, can download it. So this is my template for a very simple deployment pipeline where I'm downloading the package from the build pipeline. I'm installing the PAC CLI, and I'm deploying the solution through Power Platform build tools. And I'm using a service connection with workflow federated credential, which is quite better than what we were used to. This is kind of a new thing. So let's see if we can show it. So we created the files, and now we need to send a pull request for those files so they can actually get from my pipelines branch to the main branch. I made a mistake somewhere. Oh, I did not push this. Okay. Okay, here is my pull request. Here are my two pipeline files. So I will complete it. And here I can create pipelines again through the CLI from the definition that I just pushed to the main branch. Yeah. So I'm missing $1 here. I do have a mistake here. Okay, so if we switch here, the pipelines should be created. Yeah, so we see build and deploy pipeline. And here I would be creating a test environment. I will not be able to make it on time, so I'm skipping that part. And what's really interesting, because this is a new feature, is the configuration of how my deployment pipeline will authenticate against the Dataverse environment. So if I open it in edit mode, yeah, that's probably the problem here. You can see that it uses the deploy package with the service connection here, which does not yet exist in Azure DevOps, but I can create it here from the command line by first creating an Azure app registration and then creating the service connections with it. And I will also create this federated identity credential in the app registration. So the Dataverse can use tokens issued by Azure DevOps without me handling any sort of client secret. So you can inspect the script later. The important thing is that it creates an app registration in Entra ID, then it creates a service endpoint in Azure DevOps. It adds the federated credential to the Entra ID application, and then my pipeline can start calling the Dataverse API while having the token issued by Azure DevOps agent. Yeah, so you can see now my application was created. It jumped directly to Entra, so I can see my application detail. If you set up pipelines previously, you know that you needed to create a client ID, client secret, and move it to your pipeline. Here, instead, I created a federated credential, which then removes the requirement to set up the authentication with client secret on the DevOps side. So if we open the service connection to Power Platform here, you can see it uses workload identity federation. So no client secret here. We have granted it access for all permissions. We granted access all pipelines the permissions. And now if I ran the deployment pipeline, it could authenticate against the environment, which doesn't exist yet. So we're out of time. You can have a look at the rest of the demo online, and I will conclude it with this. So I'm just grabbing contact information for people who are interested in development of this. We're planning a conference next year, so I'll be notifying them about these code first things that we're preparing and contributing online. So if you're interested, drop your contact here. And I would also like you to evaluate my session so I can improve it next time, and that can be done with this code. So thank you very much. If there are any questions or you're interested how the rest of the demonstration evolves, I will be around here and I'll be happy to show you. Thank you.